What was there before the Big Bang? It's one of the deepest mysteries in science. Did time itself begin 13.8 billion years ago? Or is our universe just one chapter in an eternal cosmic story? Today, we'll explore the science and the philosophy behind one of the biggest questions humanity has ever asked. Part 1. The Classical Big Bang. According to the classical Big Bang theory, the universe began from a singularity, an infinitely dense point where space and time as we know them simply didn't exist. The moment of expansion, known as cosmic inflation, set our universe on its current path of expansion. But here's the problem. Singularities are not really explained by physics. They're where our equations break down, and if time itself began with the Big Bang, then asking, what was there before, might not even be a meaningful question. This puzzle pushed physicists to look beyond classical physics, toward quantum models of the early universe. Part 2. The Hartle-Hawking no-boundary proposal. One of the most influential ideas comes from physicists James Hartle and Stephen Hawking, the no-boundary proposal. Instead of a singularity, they proposed that the universe began as a quantum state. Imagine the universe not starting with a sharp edge, but smoothly transitioning into existence. In this view, time in the earliest moments didn't behave like it does today. It was more like a spatial dimension, gradually transforming into what we now experience as flowing time. Part 3. The wave function of the universe. To understand this, think about the wave function in quantum mechanics. For particles, the wave function tells us all the possible states they can occupy. Hartle and Hawking extended this idea to the entire cosmos. The wave function of the universe suggests that our reality isn't tied to a single fixed history. Instead, the universe could have had many possible pasts, each with its own probability. The universe we live in today is just one of those many possibilities that emerged from the quantum state. Part 4. Analogy. The hill and the road. This is a crazy analogy. Imagine standing at the top of a smooth hill. As you walk down, the slope flattens until it becomes a straight road. The top of the hill is the quantum universe, where time behaves like space. The flat road is the classical universe, where time flows normally. There's no abrupt beginning, no sharp edge, just a smooth transition. Part 6. Entropy and the arrow of time. But what about time itself? When the universe began, it started in a highly ordered, low-entropy state. As it expanded, entropy, or disorder, increased. This increase in entropy is what gives us the arrow of time. Without it, there would be no past or future, only a timeless quantum state. Time, in a sense, began rolling forward like a ball down a hill. Part 7. Penrose's cyclic universe. Physicist Roger Penrose has proposed a radical idea called conformal cyclic cosmology. He suggests that our universe is just one of many eons, an infinite cycle of universes. In this model, each universe expands, ages, and eventually fades. Over unimaginable timescales, all matter decays, and only massless particles like photons remain. With no mass, the distinction between big and small disappears, and the stretched-out universe of one eon transforms smoothly into the dense beginning of the next. In this view, the Big Bang was simply the handoff from a previous universe. Part 8. String theory and colliding brins. String theory offers yet another possibility. It imagines our universe as a three-dimensional brine floating in a higher dimensional space. The cyclic brine model suggests that our Big Bang was triggered when two brines collided, releasing enormous energy and creating a new universe. This cycle could continue forever: expansion, collision, rebirth. If this is true, then the Big Bang was not the first moment of existence, but just one chapter in an eternal story. Part 9. The nature of time. So, is time itself fundamental? Or is it just an illusion that emerges under certain conditions? If time began with the Big Bang, then asking, what came before, might not make sense at all. But if the universe is cyclic, or if quantum mechanics allows multiple possible pasts, then time may extend infinitely in both directions. The truth is, we don't yet know. For now, the origin of time and the universe remains one of the deepest questions in human thought. And maybe, just maybe, by searching for what was there before the beginning, we'll get closer to understanding not just the universe, but our own place within it.